Hello everyone, my name is Angie Poggi, and in this video we're going to discuss confidence intervals. Confidence intervals are needed to estimate parameters, meaning the population mean or proportion, through the point and interval estimation. The confidence level of a confidence interval refers to the success rate of the method in capturing the parameter in question. For example, a 95% confidence interval for mu is constructed in such a way that 95% of like intervals will capture mu and 5% will not capture. The confidence intervals are set only when the sampling distribution is normal or approximately normal. The confidence interval formula consists of a point estimate plus minus the margin of error. The margin of error consists of a critical value related to the significance level for two tails multiplied by the standard error. To estimate the population mean, we will calculate the confidence of mu using the formula x bar plus minus the z-value related to the significance value multiplied by the standard error. When the population standard deviation or sigma is known, our standard error will be sigma divided by the square root of n. When the population standard deviation or sigma is unknown, we will use the sample standard deviation to calculate the standard error. Confidence intervals can also be used to predict whether a two-sided hypothesis test will be significant at the alpha level of significance. When the value of the parameter identified in the null hypothesis falls outside the interval, the results will be statistically significant, and so we will reject the null hypothesis. When the value of the parameter identified in the null hypothesis is captured by the interval, the results will not be statistically significant, so we cannot reject the null hypothesis. Let's do an exercise using StatCrunch. The exercise reads as follows. Compute a 95% confidence interval for the mean birth weight for a sample of 1,000, where the mean birth weight is 110 ounces and the sample standard deviation is 20 ounces. Because the summary data are provided for the sample, we will use the t-distribution. Remember that if sigma or the population standard deviation was given, you will use the z-distribution. In StatCrunch, click on Stat, t-stat, one sample with summary. You will then enter the data provided in the appropriate fields. Sample mean is 110, sample standard deviation is 20, and the sample size is 1,000. Under the Perform section, you must select confidence interval for mu and leave the level at 95%. Click on Compute. The output will provide the 95% confidence interval results for the mean with a standard error of 0.632, 999 degrees of freedom. The lower limit is 108.759, and the upper limit is 111.241. Therefore, we conclude that we are 95% confident that the true mean or the population mean of full-term infants weight from this given population is between 108.759 and 111.241 ounces.